This is Sam. He has tried to dunk so many times you can't even imagine. He has tried over and over and over. But he has something that stands out in the least, which is shooting. We have often drawn comparisons with him with the greatest of all time. That is...
They do have a timeout. Decide not to use it. Curry, way downtown. Bang! Bang! Oh, what a shot from Curry! And he ties the NBA record with his 12th three-pointer of the game. The brilliant shooting of Stephen Curry.
Here's Sam's and Steph's shooting mechanics in action.
Wanna be like Steph?
You can't.
But with this equation,
You can.
here's the brains behind this equation.
So alright, now we are going to calculate the equations of the trajectories of basketball thrown by Sam. According to the standard size of a basketball court, 675 centimeters is the distance between the 3-point line and the basketball hoop. 305 centimeters is the height between the basketball hoop and the ground. Now we'll move the whole diagrams to an x and y axis. So I'll use the ball as the origins 0 and 0. And we will get these 3 points, the maximum height of the ball before it hits the loop, and the height of the ball when it hits the loop, and the origin point 0 and 0. We all know that whenever we have these types of graph, it is in the form of ax squared plus bx plus c. But I will put the negative sign in front of a because the graph has a maximum point. So the a must be negative and we'll sub the values into the equations minus ax squared plus bx plus c. And we will get two simultaneous equations. With the help of calculators, we can calculate the values of a and b. Hence, a is 1.781, e minus 3 and b is 1.387. So we will plug in the values and we will get these equations. Now we are going to find the angle of the ball with respect to the horizontal axis when it is at the starting points 0 and 0. We are going to use dy dx. When we differentiate these equations, we get this. When x is equals to 0, which is when the ball is initially thrown, dy dx, which is the gradient, is 1.387. So we know that the tangents to the graph of trajectories of the ball at that point is 1.387. This is the gradient. Y is equals to mx plus c, and when we plug in the values of x, we will get these equations. With these equations, we know that when x is 0, y is 0. Well, we'll get y is equals to 1.387x. So now we are going to find the angle. When we rearrange the equations, we will get y per x is equals to 1.387. We know that opposite over adjacent is equals to 1.387. We will then use tangents theta is equals to 1.387, and we will get theta is equals to 54.21 degree.
Well, there you go, that's the angles at which the ball is initially thrown.